For the third day of reviewing functions, we're going to look at analyzing functions. So when we look to analyze functions, things that we look for: rate of change, individual input and output points, all the information that can be gained just from the picture. So in this first one, let's record the slopes of each individual section. So section number 1, we do want the slope, so rise and run. We go from this point to this point, up 1, right 2. Both of those motions are positive. Up 1 is positive, right is positive. So that has an 1/2 slope. Section 2, it's not linear, so we aren't able to record the slope directly. I mean, if we were to take the first part of it, it's a very steep line. But if we were to analyze the very last part of it, it's not as steep as it was to begin with. 2, we're going to say not constant, or the symbol NA, which means not applicable. It's not possible to find a slope of this one. We could find a average if we wanted to go from here to here. But we can't find one perfect slope. Where's this now? Section number 3. We're going to estimate it from this point to this point. My lines are perfect, so we're just going to go from that point to that point. 1, 2, 3, 4. Dropped 4. Ran 1. And then for the fourth section, it doesn't matter which coordinate points we pick. It does not rise. It just has run. And those are the slopes of each individual section. What a graph can help us with is telling us outputs from given inputs. So if I plug in 2, remember that's an x value, what I want to know on this side is the y value. Basically they're asking, alright, what's the coordinate point 2 comma what? This one is asking, what's -3 comma what? We come to the graph. X is 2. So they're asking, where does our graph cross with 2 right here? Well, crosses at this point. So at 2, it's at 4. The coordinate point would look like this. I'm going to clean this up now a little bit. When we input 2, it spits out 4. Now we concern ourselves with -3. It's right here. Crosses right there. That's -1. Functions can also ask you to find inputs for a given output. So this 2 is the output. They want to know the input for this problem. It is the exact reverse of what we just did. They're asking, alright, if my y coordinate is 2, what are my x values at these points? So similar to the last one, instead of going through x is 2, we want to go through y is 2. Right there. Crosses perfectly at this point, crosses perfectly at this point. Looks like there's only 2 coordinate points, so we don't need this third one over here. The first one's at 1, 2, 3, 4, 5, 6. -6. and our second point is over here at positive 2. So what x values have an output of 2? These two. Negative 6 and 2. Negative 6, 2. Maybe we've got an entire section right here. Let's find the rate of changes on all of them. So section 1, section 2, section 3, section 4, section 5. Didn't space that out well enough. I'm going to start over a little bit. 1, 2, 3, 4, 5, 6, 7. Section 1 has a 3/1 slope. Section 2 is a 0/1, 0/2. Doesn't really matter because it's 0. C to D, we go 1, 2, 3, 4, 5. 1, 2, 3. Down 5, right 3. The exact same as if we had decided to start from point D and go to C. We would not accept this one as an answer because two negatives can be simplified to a positive. Section 4 goes from D to E, that is up 1, right 2. 5 is up 2/2, or we notice it's up 1, right 1, simplified. Section 6 is not a linear function, so we aren't able to find the rate of change or the slope. And then section 7 is negative 1/4. Also would have accepted that one. Let's go through and let's highlight all of the negatively sloped regions. Section 3 is a negative slope, and so is section 7. They both drop from left to right. Non-linear would be section 6 here. Because it is not a perfectly straight line. If I wanted to, the last thing we're going to do with this graph, because it's getting kind of busy, is I want you to use this graph and tell me what number do I get when I plug in for negative 2. We find negative 2, that's in the x's location, so you find negative 2 on the x. Come down to where the graph is present, and we get negative 4. Last thing we're going to talk about is context within these problems. So this graph I have right here can actually convey a story based on the units, distance and time. So if we start right here, our starting point, I'm going to start with one unit of distance. Let's say feet, and let's say time is in minutes. So to start off our story, you start with a 1 foot head start. The slope of this next section right here, the slope, conveys how our distance is changing compared to time. So our slope is 1, 2, 3, 4/2, or 2/1. So in this next section of story, I'm going to say that I gain 2 feet every minute. Next section of our story. My slope doesn't change, 0 over 2, so my distance doesn't change. Basically, I stand still for 2 minutes. Wherever I stopped in this story, I'm going to stand still. Maybe I'm running to the bus stop, and I'm at my house, and or 1 foot away from my house, and then, so feet wouldn't make sense if I'm running to the bus stop. Probably yards, maybe miles, I don't know, if we're driving. We go somewhere, and then that distance, I'm just standing there. The next section, I gain some more distance. It is still a positive slope. It is 1 over 2. So the next section of our story, we have to incorporate that. I gain 1 foot in 2 minutes. Then we get to the negative portion of our story. That is negative 4 over 1. So this next part of the story, I have to lose 4 feet in a minute. I then have to lose some more because I'm still at a negative slope, just a different rate. This one is negative 1 over 4, so like the flipped version of that. Ah, 4. So I lose 1 foot in 4 minutes. Come back to our next part of the story. It's back to being positive. I have to gain 1 over 3. And then to finish it out, color I haven't used. Lime green. The last part, we have to lose, what is that, 2 feet in 3 minutes. So each slope has a context using whatever these variables happen to be. If I were to change it from distance to time, instead of distance are maybe cookies. So I start with 1 cookie, so it knows every time we see the word foot or feet, we'd use the word cookie. So I start with a 1 cookie, would be a head start, even though it'd be kind of funny if we did have a head start for cookies. I have to gain 2 cookies every minute. I then stand still for 2 minutes. I gain another cookie. I lose 4 cookies. I lose 1 cookie. Gain 1, lose 1. All based on our variables that we have listed in our problem.